Hello and welcome back to Calculus 1, section 3.5, derivatives of trigonometric functions. Very good. So, we have seen polynomials, exponential, logarithmic, all of this good stuff. We have 6 trigonometric functions to discuss. They all have derivatives, and we would like to know what those are because we would like to find those tangent lines. And the tangent lines measure what? Tangent lines, slope of tangent lines measure change, instantaneous change. Very good. All right. So, I'm going to derive derivative of sine x because I'm awesome. The book has it. You can read it. You know all the letters and symbols and stuff. But I'll do it still. And then I will write those 6 shortcut formulas. Remember? Right? We say you either do the limit every time you need a derivative, or you memorize the shortcut formulas and then go from there. So to start off, we have these 2 special limits which we are memorizing now, and we will discover in chapter 4 at some point how do we calculate these limits. So right now we just memorize them. So special limits. One says that the limit x goes to 0 of sine x over x is equal to 1. So that's one of the limits. And the other one is that limit x goes to 0 of cosine x minus 1 over x is equal to 0. So these are 2 special limits. And we are going to use these now to calculate the derivative of sine x. The way to calculate derivative is to compute the difference quotient formula with the limit as h goes to 0. So I will have sine of x plus h minus sine x divided by h. So this is what we are supposed to compute. The way this goes is the only thing we can do is use sum of 2 angles formula for sine to expand sine of x plus h. So that would be sine x cosine h plus sine h cosine x, and then we have minus sine x divided by h. So that's the formula. We use this formula to expand this sum. That formula is in trigonometry course. So now we factor, we factor sine, and we split this into 2 limits. So we start with limit h goes to 0, and then I factor out sine x, and then you can say sine x over x, and what's left is cosine h minus 1.
Sine x is canceled out.
No, you're factoring between these 2 terms. So when you factor out sine x, you get cosine h minus 1. It's over h.
Okay.
Let's do it this way.
What about the sine h?
I said we're splitting the limits, right?
Yes, sorry.
Patience, young Padawan. Cosine x over h. There we go. So what we have done here is we use the first and the third term, factor out sine of x, and then we use the second term over here to give this a completely new limit. So we just rearrange this using algebra. Now, we know that for limits, we can separate multiplication as well. So I have limit of sine x times the limit of cosine h minus 1 over h as h goes to 0. Plus, here I have limit h goes to 0 of cosine x times the limit h goes to 0 of sine h over h. And this is where the special limits come into play, because this limit is equal to 0 by the special limit, and this puppy over here is 1. So what we get is sine x times 0 plus cosine x times 1. So the whole thing is cosine x. So we learned that the derivative of sine x is equal to cosine x. Cool. Come on, get excited. Because it could have been much worse. Can you imagine if it was like e to the 6x cubed minus ln 5x plus tangent x, right? Yeah, I know. So it's beautiful. Derivative of sine x is cosine x, and we move on. That's just first out of 6.
That's just true. This is a general rule that sine x is always going to be cosine x.
Yes.
Oh.
That's it. I hope you're not disappointed. Now, the derivative of cosine x is negative sine x. I'm going to put some space over here so I can title and stuff. The derivative of tangent x is secant squared x. The derivative of cotangent x is negative cosecant squared x. Two more. The derivative of secant x is secant x tangent x. And finally, the derivative of cosecant x is negative cosecant x cotangent x. Derivatives of 6 trigonometric functions. Now, let's observe some symmetry so that we can easily memorize all of these limits. Not limits, derivatives. Ready? Good. Sine, cosine, tangent, cotangent, secant, cosecant. Do you see that their forms for their answers are always the same? You have a single trig function, a function squared, and then two of those functions, right? Do you see that symmetry?
Yeah.
Great. Do you see that all of these are negative?
Yeah.
So the derivative of functions is all negative, right? Each one. You can start with cosine, cosecant, cotangent, right? Good. They're all negative. The non-cut are all positive. And then one of the most important things to realize is that functions are always paired. You have a sine-cosine pair. You will never see tangent with cosine or secant with sine or anything like that. What are the other two pairs? One pair is sine, cosine. What's the other? What are the other two?
Tangent and cotangent, secant, cosecant.
No, no.
That was one pair.
Sine is always paired with the cosine.
Okay.
Secant is always paired with tangent. See? All the tangents and secants are on the pile. There are no cotangents, no cosecants, no sines, cosine.
Nice.
So, pairing.
Cosecant and then cosecant. Cotangent.
Sine x with cosine x, secant x with tangent x, and cosecant x with cotangent x. So this pairing is preserved also to trigonometric some of the trigonometric identities, the ones that we need, namely Pythagorean identities, and this will be preserved also through integration later on. So knowing and seeing the pairs right now really helps down the line. Great. So what are we supposed to consider now? Well, first of all, most of the time, you are not going to see derivative of sine or tangent or something like that of x. You are going to see the derivative of sine of 5x or tangent of 4x or something. So, most of the time, you are going to see the derivative of sine ax, where a is some number. Could be a half, could be 3, whatever. And these are the ones that you should be spending time with. And the answer for this is, well, the derivative of sine is cosine, so the answer is a cosine ax. Now you apply this to all 6 up there. For instance, the derivative of secant ax, right? Ax is like the argument, right? Is going to be a secant ax tangent ax. So all of those will pick up this a in front and keep a in their argument. So what is cosine, the derivative of cosine of 3x? What is it? Negative 3 sine 3x. Yes. Good. What is the derivative of tangent x over 2? Yes?
X over 2 secant squared x over 2.
1 over 2. Secant squared x over 2.
Why would you put the 1?
Do what?
Why would x become 1?
No, the a is 1/2 because x over 2 is 1/2 times x. You don't bother x. A is 1/2. You see the 3x over here?
Yes.
It was not 3x over here. It was just 3. So it would be just 1/2. And now, what is the derivative of x squared times cosine 2x? You think you know the answer.
I'm like 80%.
80%. Is it going to be as good as you guessed earlier? Because that.
I actually was right. Bonus points. Bring it up.
Oh, good. So what do you got?
2x times negative 2 sine 2x. No?
Wait, what are we supposed?
Theta?
What are we supposed to do?
Yeah.
Yes, we have to use the product rule.
I thought you could just.
Yes, we learned right after the exam that we have f times g, and then there is that f times g prime plus g times f prime formula that you have to do. Got it? Factored it? Yeah, wow, now I'm pushing my luck, huh? It's like, wow, it's one thing to demand the product rule, but now it's factor it at the end. That's a completely new level. It's terrible. All right, let's take a look together. So copy the first function, which is x squared, that's our f, times the derivative of cosine, that will be a negative sign, and then we have the 2, so it's negative 2 sine 2x, and then plus g as is, which is plus cosine 2x, and then the derivative of x squared is 2x. So our formula is now done. That was the product rule from last class. And now we can fix that as negative 2x squared sine 2x plus 2x cosine 2x. We can factor out 2x, and I'm just going to swap these, so negative is second, so cosine 2x minus x sine 2x. And this is the factored form. You can now set this equal to 0 and in chapter 4 and do the rest of the math. One more problem, which sometimes I even include on the exam or something similar. Prove that the derivative of tangent x is equal to secant squared x. Where would you start? No coughing. Where would you start? The derivative of tangent, not secant. What? Yes?
Because what he means, where you have secant x times tangent x, multiply that by multiply secant.
Nope. Nothing to do with secant at all. Yes? Differential. That would be too annoying. There is a much easier way, which includes the last lecture. What can we write tangent as? Sine over cosine, and then unleash quotient rule upon it. Very good. So the derivative of tangent x can be written as sine x over cosine x, and then you can use quotient rule, which you know from last class, obviously. Totally practiced all of this over the weekend. The two formulas we learned last class after the exam. one for product and one for quotient rule. You have function f, function g, and then f prime is the derivative of f, and g prime is the derivative of g. And so the answer is obviously right there. And you guys can try also secant as 1 over cosine, cotangent as 1 was cosine over sine, and so on. So you have those, all 4 of those formulas in here are obtained using quotient rule on the trig identity. So you can practice those. And that's that. We can find the tangent line. Yeah, you love tangent lines. Great, let's do it. How about a tangent line to secant x at pi over 4, because you went so well before? Let's see what you get.
Was it pi over y?
Pi over 4.
Pi over 4. Where you get y? Okay. Ready? Yes? So for the tangent line, as we talked about earlier, we find the derivative of the function. What's the derivative of secant x?
Secant x times tan x.
Good.
X.
And then to calculate the slope, we plug in the point. So slope is the derivative computed at the point that we are interested in. So this is going to be secant of pi over 4 tangent of pi over 4, which is square root of 2 times 1 equal to square root of 2. Then, to find y value, we plug in pi over 4 in the original function, so that's going to be secant of pi over 4 only, which is square root of 2. And we have everything. Slope is root 2, and the point is root 2, no root 2, pi over 4, root 2. Y equal mx plus b. Y is root 2, m is root 2, x is pi over 4, plus b. B is equal to square root of 2 minus square root of 2 times pi over 4. If you want to be fancy, you can factor out root 2, have 1 minus pi over 4. And then y equals root 2x plus root 2, 1 minus pi over 4. And that would be the tangent line. Sure, you can get decimals and stuff, but no one cares. So this is the tangent line. At x equals pi over 4.
Okay, use our calculator. Where's the find value? Secant pi over 4.
Yeah, it's gonna give you decimals, but it is what it is.
I don't know. Secant pi over 4 will be 2.